Okay. So today we'll be discussing about primal dual. So we'll be discussing about primal dual. So this piece of the discussion would be recorded for your reference. After this, I'll be discussing about the assignment 1 solution. So this will not be recorded because we want you to come and join and have a discussion with us. So this will be in the second half. So it will not be recorded. I'll first finish off with primal dual of week 5, and then we can go into this. Okay. So that will be the agenda for today's discussion. With that being said, let's talk about primal dual. How many of you have seen the videos of week 5 where we discussed primal and dual? Yeah. Okay. So at least I have 2 people. Okay. So to explain this, what I will do is I will try to give you a scenario. All right. So I am a manufacturer. I'm going to make 2 types of products. Yes, Mulanani.
Oh, sorry. My system is acting up. I'm sorry. I don't know what's happening. Please continue.
All right. Okay. So I'm going to discuss this topic of primal and dual through the eyes of an example. All right. So let's say I am a manufacturer of toys. So I make toys, and I'm going to make 2 types of toys. One is, let's say, cars. The other is dolls. So there are 2 types of products. And whenever I sell a car, I make a profit of, let's say, rupees 24 per unit. And whenever I sell a doll, I make a profit of rupees, let's say, 6 per unit. So I have 2 products. I make a profit on the 2 products that I sell. To make these 2 products, I require 2 raw materials. And I have 2 raw materials, R1 and let's say R2. Now what is said is, for every car, I need 6 units of R1 and 1 unit of R2. And for every doll, I need 4 units of R1 and 2 units of R2. Okay. So that is the requirement for me to make 1 car and 1 doll respectively. And I am having every day, I purchase 5 units of R1. Oh, sorry. My bad. So every day, I'm going to produce 24 units of R1. I'm going to purchase 24 units of R1 and 6 units of R2. So this is what I'm going to purchase. Since these numbers are same, let's just change that. Let's say for every car, I make a profit of 5 rupees, and every doll, I make a profit of 4 rupees. So that is my problem. I have set up my problem. So the question now is, how many cars and how many dolls should I make every day? So that is going to be the question that I am asking you. So I am a manufacturer. I'm just repeating the problem for the sake of completeness. I'm a manufacturer. I make 2 types of products, cars and dolls. And when I sell a car, I make a profit of 5 units. When I sell a doll, I make a profit of 4 units per unit. And I need 6 units of raw material 1 to make a car, and 1 unit of raw material 2 to make a car. Whereas when it comes to a doll, I need 4 units of R1 and 2 units of R2. right? So that is the raw material requirement. And every day, I'm going to purchase 24 units of R1 and 6 units of R2. We are going to solve this problem under the assumption that whatever I make, how many cars I make, I will be able to sell all of them. How many dolls I make, I will be able to sell all of them. So the demand is always there. Given this problem, how do you solve it? Is the first question that I'm asking you. So how do you identify how many cars to produce and how many dolls to produce? What would be your objective?
Maximizing the profit.
Super. So I am a manufacturer. I have ultimate demand. I must maximize my profits while satisfying the demand. So that is going to be the objective. So we are going to solve this as a linear program. We are going to formulate this as a linear program, and any linear program will have three key entities. All right. It will have something known as the decision variables. It will have something known as the objective function. And finally, it will have something known as the constraints. Yes, yeah. Constraints. Okay. So my objective is to maximize the profit for this problem. So what are my decision variables? Decision variables are basically what I have to find out. So this is nothing but what I want to find. So what are my decision variables for this problem?
R1 and R2.
R1 and R2.
Number of cars and number of dolls.
I don't want to find out. I don't want to find out R1 and R2. R1 is given as 24, R2 is given as 6. I want to find out how many cars I should make every day and how many dolls I should make every day. So that is what I want to find out. So that will become the decision variables. So I will have a decision variable x1 and x2, or you can call this y1, y2, z1, z2, p1, p2, whatever you want. X1 and x2, there are two decision variables. One is going to be number of cars to make, and x2 is going to be number of dolls that I have to make. That is going to be my two decision variables. Okay. So what would be my constraint? What puts bounds on these x1 and x2?
The availability of the raw materials.
Exactly. So when I make a car, so to make cars and dolls, I need raw materials. So based on how much I make, x1 and x2, I need so much amount of raw materials, or let me put it the other way. Based on, since I have to find this, based on availability of R1 and R2, I need to find x1 and x2. So those are going to be my constraints, right? So that is going to be one constraint. I'll come to that mathematically like this in a minute, but I'm just putting it in words first. So this is going to be one constraint. The second constraint is that x1 and x2 cannot be negative. Right? I cannot make negative number of cars or negative number of dolls. So they cannot be negative. So these are the two constraints that I will be putting for my problem. So this way of writing your linear program in words, this is known as the verbal formulation. So once you create a verbal formulation, converting it to math would be very simple. Now let's do that. We are going to convert this verbal formulation into math. So when I'm doing it into math, when I say maximize profit, how do I write that mathematically? Using x1 and x2. Anyone?
Profit multiplied by x1 and profit multiplied by x2.
Exactly. So I'm going to make X1 cars and I'm going to make X2 dolls. That is what I want to find out. So when I make X1 cars, each car I'm going to make a profit of 5 rupees. So 5 into X1 plus, and every doll that I sell, I'm going to make a profit of 4 rupees. So 4 into X2 would be the profit that I get when I make X1 cars and when I make X2 dolls. So I want to maximize this. So this is the objective function, maximize 5x1 plus 4x2. So that is my objective. All right, everyone clear up to this point? Okay. Then comes the question of available raw materials. Now, since I have 2 raw materials, I must make sure that the availability for R1 and the availability for R2 are met. So when I talk about R1, right? When I talk about R1, to make 1 unit of a car, how many raw materials do I require?
6 R1.
Okay, so I need 6 units of R1 when I produce 1 car, and how many units is required when I produce 1 doll?
4 R1.
4.
4. So 6 plus 4, 10 units would be required if I produce 1 X1 and 1 X2. But I am going to produce some X1 quantity and some X2 quantity. So 6 into X1 plus 4 into X2 is the total amount of raw material R1 which I would require when I produce X1 cars and X2 dolls. And this must be up to what limit?
24.
24, because I have only 24 units. So when I say up to 24, what should be the sign that I put?
Less than or equal.
Less than
Less
equals
than or
to.
equal to. So when I make X1 number of cars and X2 number of dolls, since each car is going to take 6 units of X1 and each doll is going to take 4 units of resource 1, 6X1 plus 4X2 must be less than or equal to what is available for me, which is 24. So this is the constraint for R1. Similarly, can someone tell me what is going to be the constraint for R2?
X1 plus 2X2 is less than equals to 6.
X1 plus 2X2 is going to be less than or equal to 6. Why? Because every car requires 1 unit of R1 and every doll requires 2 units of R2. So X1 plus 2X2 is less than or equal to 6. And this is going to be the first constraint. Based on the availability of R1 and R2, I need to find X1 and X2. So X1 and X2 less than or equal to 24 and less than or equal to 6 are my 2 constraints that capture this requirement. Finally, X1 and X2 cannot be negative. So I will say X1 must be greater than or equal to 0 and X2 must be greater than or equal to 0. This is known as the non-negativity constraints. Right? So this will come for most of all of your problem. So non-negativity, the actual constraints for the problem, the objective function, and the decision variables. Now you have formulated a problem. Is this a primal or is this a dual?
This is primal.
Why is it a primal?
That I don't know, but
Right. So it is a primal, but can someone tell me why it is a primal?
Because we are trying to maximize, our objective is to do maximization.
Okay, but that is not the exact answer. That I'll come to that in a minute. What is meant by maximization, so on and so forth. But why is this called a primal? Why is this called a primal for this problem?
Because we're maximizing the objective function.
no. So you are, sir, maximizing the profit, not minimizing the loss.
No, I can still put, if I, instead of saying 5 units of, I'm just entering the market, instead of saying rupees 5 per unit, I can say every item is going to cost me 5 per this thing to market, for example, and 4 to market. I must produce and x1 and x2 is the spending on different markets, for example. Then I can still put a minimization function and still call the primal and still call the primal. What drives a primal?
Basically, primal is maximizing the profit function and minimizing the operation functions, and dual is opposite, minimizing.
Not necessary. Not necessary. That is why I'm trying to ask you. So that is all the standard form. I'll come to the standard form in a minute. You're all memorizing the standard form and telling this is why it's a primal. Actually, it is not. When I talk about a primal for a problem, I could have a maximization function. I could have a greater than or equal to constraint. Let's say I say this x1, when I produce x1, it should use at least 50% of the raw materials, for example. So 6x1 must be greater than or equal to at least 0.524. I could write a constraint like this. 24 by 2, 50% of the raw materials must go to at least the 6, must go to at least x1 that is being produced. I could write some constraint like this. Just because you have a greater than or equal to does not mean this is not a primal. So what drives a primal is what question is being asked. Here, the question that is asked is how many cars I should produce and how many dolls that I should produce. So this is the primal, because that is x1 corresponds to the number of cars that I should make and x2 corresponds to the number of dolls that I should make. That is why it's called the primal, because my decision variables directly answer the question that I am targeting at. Okay. So for someone else, when I formulate the dual, I will tell you why the dual will be the primal for someone else, and this would become the dual for that guy, right? But that is what drives the primal. If your decision variables directly answer the question that you want to ask, that is asked to you, then the formulation that you have created using those decision variables, that becomes the primal. It does not depend on maximization. It does not depend on whether the constraints are less than or equal to, greater than or equal to, or equal to. That and all does not drive a primal. That just tells you if you convert it to a standard form, it is good. Everyone clear? Why this is the primal? Because the decision variables here directly capture the requirement for my problem. Okay. Right. Let's leave this out. So with that in mind, now I will answer. Yeah.
Sir, one small thing, sir. I just joined a little late. I am not able to understand 661 plus 4x2 less than 24. So what is 24 and 6?
24 is the amount of R1 available to me. Every day I'm going to buy 24 units of R1. 6x1 is the number of units of R1 required to produce the cars.
Okay, got it. So this is the R1. 24 is the number of available unit of R1 and
R1. 6, 6 is the number of available units of R2.
Okay.
Sir, would it be possible for you to repeat the difference between the ML and the dual?
What I will do is I will just hold on to that thought. Okay. Once I do the primal, I will do a comparison. At the time, it might become more clear.
All right.
Okay. Just hold on to it. I'll re-explain it once more. Fine. So this formulation will correspond to the what was the word that I was using? I just forgot. Standard form. Yeah. The standard form of a primal. Right? So in a standard form of the primal, the objective function must be maximization type. The constraints must be less than or equal to type. And the non-negativity will be greater than or equal to 0. So when your decision variables are of the form of greater than or equal to 0, your constraints are of the form less than or equal to type, like these, and your objective function is a maximization, then you are actually having a problem which is in the standard form, the primal standard form. It does not mean that a primal is not a primal if I have a minimization function, or if I have greater than or equal to, or if I have decision variables which are unrestricted, right? So that does not mean that it is not a primal. We'll convert it to a standard form and then solve. So this type of a problem is known as a standard form of the primal. So first I will talk to you about the standard form. So first I will talk to you about the standard form. Then I will talk to you about how do you convert things which are not in standard to the standard form and then solve. Okay, that is what we will do. Fine. So now once something is created into a standard form, how do you convert it to a dual? So to convert a standard primal to a dual, all you have to do is ulta everything that is there. Okay. So the objective function of the dual will be the ulta of this. So ulta of max is going to be min. The constraints in a primal were less than or equal to type. So the constraints in the dual will be greater than or equal to type. Non-negativity constraints alone remain the same. So in this case, they will be equivalent. Here also decision variable is greater than or equal to 0. Here also decision variable is greater than or equal to 0. This will not change. Please note that this will not change. So this will not change. The other two will just become the ulta. If it's a maximization, minimization, if it's a less than or equal to, it will become a greater than or equal to. So once you convert something to the standard form, then the ulta of that becomes the dual. Okay. So let's do that. So if I'm going to do a dual in my primal, first thing we have to understand, in my primal, the x1 corresponds to the number of cars that I want to produce. The x2 corresponds to the number of dolls that I want to produce. So in a dual, what I would be looking at is two decision variables which will not capture x1 and x2, but will capture r1 and r2. What is the unit worth of a resource r1 to me? What is the unit worth of resource r2 to me? Right? So I want to reduce the cost associated with raw materials is something that you can think of it in analogous term. If I reduce the worth of a resource to me, automatically I'm going to start producing more excess, which means I will start producing, which means I'll get more profit. So that is how it drives. So in a dual, the decision variables or the number of decision variables that I will have, number of DVs in a dual is going to be equal to the number of constraints in the primal. I will put a clause in bracket because this would be the easiest method. In the primal, when it is in the standard form. Okay. So when I have converted my primal to a standard form, when I've converted my primal to a standard form, the number of constraints that I have, that will correspond to the number of decision variables in the dual. Yeah, any questions?
No.
All right. So the number of constraints that I will have in the primal will correspond to the number of decision variables that I have in the dual. So how many constraints do I have in this primal?
2.
Exactly. So I have these two. Do not consider the non-negativity. Only the 2. So in the dual, I will have two constraints, two variables, y1 and y2. Y1 corresponds to the constraint of R1 and y2 corresponds to the constraint. Let me call this for R2. Constraint for R1, constraint for R2. How do you define Y1? Y1 is defined as the unit worth of raw material R1 and R2 refers to the unit worth of raw material R2, right? So Y1 corresponds to the unit worth of raw material R1, Y2 corresponds to the unit worth of raw material R2. So that is my definition of my two decision variables in the dual. Now I have to write the objective function. So when I write the objective function, I'm going to put a minimization. That is blindly. Because I have maximization form, I will convert it to a minimization form. Remember, all of this is true once you have converted the primal to the standard form of the primal. So we are doing that. So we have minimize. I'm going to have some y1, something into y1 plus something into y2. What is the value that is going to sit here? What is the value that is going to sit here?
It will be 24 and 6.
Why 24 and 6?
So sir, I understand in my way. So it is now reversing. It is now a constraint minimization problem. You are doing the reverse.
Correct. You are absolutely right. I'm going to do the reverse where I'm telling there is a unit worth of y1 and unit worth of y2. And I have 24 units of y1 and 6 units of y2. So I will put 24 here and 6 here. Basically, the right-hand side of the equations of the primal will go to the respective variables coefficient in the objective function. And you do this. The reason for you doing this is I want to minimize y1, I want to minimize y2, which means I want 24 times into the cost. Consider this as a cost. If I can reduce this cost, then the entire objective function reduces. So how do I find the unit worth of y1 and unit worth of y2 for me when I have 24 and 6 available? That is the funda behind the objective function here. Just like how you try to maximize your profit, 1 unit is 5 rupees. So can I sell as many units as possible given these resources? For me, 24 rupees is the cost of 24 rupees is what I'm going to lose for every unit of y1 that I'm going to have, that I'm going to use. So let's say I have 24 units. How much cost will each unit cost me? That is going to be your y1. Got it? Got the difference between the two objectives? A profit maximization and a dual's cost minimization, basically.
What is unit worth of raw material? I'm still not getting that.
Unit worth of raw material. So let's say you want to go to the market and you want to buy y1 to make x1. How much am I willing to pay for that y1? That is the question. Correct? So that is the unit worth of raw material for me. So that is
basically it's cost. Is it cost?
Yeah, it is basically a cost. We call it unit worth. We call it unit worth because in literature you will have something known as shadow price, so on and so forth. That is why it's called unit worth, but it's basically the cost that I'm willing to pay for it. Okay?
So it is like buying the raw materials.
When I buy the raw materials, how much I will be willing to pay for it?
Correct and simple.
Okay, right. So that is going to be the objective. Now I have to, this is done. So the maximization problem is converted to a minimization problem. I have to make the ulta of the constraints. So how many constraints will I have is the first question.
2.
Why?
Because there are 2 variables, constraint variables.
2 constraint variables. Which are the constraint variables?
In the primal.
So which are the constraint variables?
X1 and X2.
X1 and X2 are decision variables of the primal, no? Constraint variables of the primal is R1 and R2. But you are right. Based on X1, X2 will be the number of constraints. So you have to tell me that it is the constraint variables of the dual. It is the constraint variables of the dual. In this problem, I had R1 and R2. I wanted to find X1 and X2. Here, I want to know what is the worth of resource R1 and R2, given that I'm going to make X1 and X2. Right? So it is the other way around. So the number of constraints in the dual is equal to the number of decision variables in the primal condition when
It's in the standard form.
When it is in the standard form. Right? So when you convert the primal to a standard form, blindly take the number of decision variables that you have, put it as the number of constraints that you have. So I have two constraints. So I will have a constraint for x1 and a constraint for x2. Okay. So how will I write these two? How will I write the constraint for x1?
Sir, can you show us the primal? It will be 6y1 plus y2 greater than or ulta, greater than equal to 5.
Why? You are absolutely correct. It's going to be.
So I
6.
make a matrix and I just transpose it.
Very good. That is the shortest way to do it. But why is this happening? Again, the logic behind it. 6y1 plus y2. Why should it be greater than or equal to 5? What is this 5?
Basically, the main constraint, profit.
It is the profit. So if I sell 1 unit of x1, I can make 5 rupees profit. So that is the right. So that is the So when I sell 1 unit of x1, I'm going to make 5 units as profit. So that if I buy a resource if I buy y1 for making x1, and if I buy y2 for making x1, if I buy one unit, I should be making something that is greater than the profit that I will get. Only then it makes sense for me to buy this at that cost. Or else it does not make sense for me to buy this at that cost. Okay, so that is why you have 6y1 plus y2 greater than or equal to 5. Similarly, the more easier method, if you're not able to understand that, 4y1 plus 2y2 must be greater than or equal to, what is the cost? It's 4, right? Yeah. What did I say? 4y1 plus 2y2. So 4y1 plus 2y2 must be greater than or equal to 4. So that is my second constraint. All right. So now I've converted the primal to a dual. I only have the non-negativity. So obviously the worth of resource cannot be negative. So y1 must be greater than or equal to 0 and y2 must be greater than or equal to 0. Fine.
Could you please possibly show the question? I would like to see the raw material.
Okay. Able to see this?
In a way, the constraints are somewhat related to raw material 1 and raw material 2.
Not somewhat related. They are absolutely related. Because I'm telling the unit worth of resource R1 is Y1 for me, and unit worth of resource R2 is related to is Y2 for me. So when I buy Y1, I'm going to make 6x1 plus 1x2. 6y. I'm going to make 1. Let me put it like this. Yeah. When I'm going to buy Y1, I must buy it such that I make a profit which is greater than 5. Correct? If I want to make x1. So to make x1, I need 6 units of y1 and 1 unit of y2. So what is the cost that I'm willing to shell out? Such that this equation becomes greater than or equal to 5.
Okay.
Right? Let's say I'm willing to spend 2 rupees for y1 and 1 rupees for y2. Then it's okay for me. I will spend 2 into 6 plus 1, that is greater than or equal to my 5. So I'm absolutely okay. We can go in for that spending. But I want to find the minimum possible value. 1 could be better, because if when I put 2 here, this becomes 48, whereas 1 becomes 24. Right? So how much cost can I reduce while making sure that my profits keep going up is the constraint. If you don't understand all of this math behind it, the simplest version that you will use to remember this guy is going to be whatever you have the coefficient for x1, In the constraints, those would go for the first constraint. So 6 plus 1y2 greater than or equal to 5. Then you are having a constraint for x2. Put 4y1 plus 2y2 greater than or equal to 4, which is the objective function coefficient of your primal 4. If I have a third thing, let's say I had something like this. I had a third guy which said 7x3, and I had a row which said like this. X3 must be x3 must be greater than or equal to 10 for raw material 3. For some reason, I'm just making this up. I'll come to a different problem later. Then, x3 must be less than or equal to 18, for example. If I put this as 18, then I will have a third constraint which says for x3, what I have to do. What will it be? If I had a third constraint for x3, what will I write?
What is the maximum?
What will I write? I'm specifically leaving it blank. What will I write?
Y3 should be less than or equal to
Exactly.
7.
Since I have a third constraint, this was constraint 1, this was constraint 2, this was constraint 3. I should not have just y1 and y2. I should have a third y3. And for that y3, I should write it as y3 must be greater than or equal to 7. And over here, I should write minimize plus 18 into y3. Making sense? Yeah, okay?
Yes.
All right.
Is it Y3 greater than or equal to?
Yeah, it should be y3 greater than or equal to 7. Correct, no?
Okay, I thought the Y3 is a cost, right? So
Look, minimization y3 is 18. Here, when it comes to the constraint, it is telling that this worth must be greater than the
at
profit
least
that it
7.
can generate.
Okay.
So y3 must be greater than or equal to 7. Right? So that is the thing. So basically, your crooked shortcut method is keep this as your shortcut for your exams. So your shortcuts are that objective function coefficients, these become the RHS of constraints. So in standard primal, in the dual. So the objective function coefficients, which were 5, 4, 7, they will become the RHS of your constraint equations. And you know that the constraints are going to be greater than, greater than, greater than. So leave that out. Then your corresponding let me put it like this. For each decision variable in the primal, the corresponding coefficient in the LHS, that will become the coefficient, will become the objective function coefficient of the corresponding dual variable for that constraint. What do I mean? So what did I write? For each decision variable in the primal, corresponding coefficient in the RHS. LHS 6 1. Oh, sorry. Okay, I've written the next one. Let me see if I can. Okay. Let me write this first, then I'll write the other one.
So it should be RHS. Right?
Yeah. It should be the RHS. The coefficients are the RHS, and this is the for each decision variable in the primal, the corresponding coefficient in the LHS will be the no, wait. I'm talking about 5. I'm writing the same thing again. Yeah. Coefficient. No, this one. 6, 4 is what I'm talking about. 6 and 4 would become the coefficient of the correct only. The coefficient of the variable in the this thing.
So left side should be
RHS of the corresponding dual variable. Yeah. Just not writing. RHS of the corresponding dual variable for the corresponding constraints. I don't know how else to put this. So y1, what I basically mean is y1 is the dual variable for constraint 1. So when I write the constraint 1, whatever coefficient is going to come, the 6, this will always correspond to x1. So 6x1 plus 1, 6y1 plus 1y2 must be greater than or equal to 5. Look at it however you want. If you want to just take the transpose, do the transpose, that is also fine. But that is what it means. For every decision variable in the primal, the corresponding coefficient in the LHS, this corresponding coefficient in the LHS will become the RHS of the corresponding variable, corresponding dual variable of the corresponding constraints, right? So it will become 6y1, 4y1, 1y2, 2y2. 6, 4, 1, 2. All right. Or did I confuse you guys better, even more? Clear?
So show the rules.
I'll write the final one also. RHS of the constraints become the coefficients in the objective function. All right. Let me do one more thing. I will write the primal and then I'll side by side write the dual so that it becomes very, very clear. So the primal is 5x1 plus 4x2. Maximize this guy such that the constraints were 6x1 plus 4x2 must be less than or equal to 24. x1 plus 2x2 must be less than or equal to 6. x1, x2 must be greater than or equal to 0. So these were the primal, the standard primal. So in the dual, my objective was minimization, minimize 24y1 plus 6y2. So these two go there. Then this 5 and this 4 would actually come to the sides, and this is maximization. So this is less than or equal to. So these would be greater than or equal to. And what will happen is this 6 will come here. This 1 will come here. So 6y1 plus 1y2 must be less than or equal to 1y2 must be greater than or equal to 5. And then you have 4y1 plus 2y2 greater than or equal to 4. This is what I mean. Objective function coefficients of the primal become the RHS of the constraints. For each decision variable in the primal, that is basically x1 and x2, the corresponding coefficient in the LHS, which is 6 and 4, becomes the corresponding decision variables 6 and 4, 1 and 2. So 6 and 4, 1 and 2 become like this. And the RHS of the constraints, which are basically 24 and 6, becomes the coefficient of the objective function, which is 24 and 6. Okay? And obviously you have y1, y2 greater than or equal to 0. I hope it is clear. Super. So after this, I just want to know, okay, someone asked me the question, why is this a primal? Why is this a dual? I will repeat the answer to that. What did we originally start off a problem with? We started off a problem with the question, how many cars should I make every day? How many dolls should I make every day? Let's call this formulation 1 and let's call this formulation 2. Does formulation 1 directly give me the answer or formulation 2 directly gives me the answer? Formulation 1 has x1 number of cars to be produced, x2 number of dolls to be produced. In formulation 2, I have y which is the unit worth of resource R1, y2 which is the unit worth of resource R2. Which formulation gives me the answer directly?
1.
Primal. Yeah.
So, yeah, so 1 is the primal for me. Whereas, let's say I have asked the question, what is the unit worth of resource y1, unit worth of resource y2 for me? Right? Let's say I was the producer of y1 and y2, the resources, and I had to sell it to a person who's making cars. So at what price should I sell y1? At what price should I sell y2? If that was the question, which would be the primal?
Second one. Yeah.
Second one. So based on the question, your primal and dual will be based on that. It does not depend on whether it was a minimization function, maximization function, whatever. That is not what drives it. What drives it is the objective of what drives it is the question what it has. So the question was, what is the unit worth of a resource? What is the number of cars to be produced? Based on that question, it will change. Making sense? Divya, is your question answered? So Divya, you got it?
Sorry, sir.
Yeah, you got the answer. I was just answering
Yes.
that for you. What is the primal? What is the dual? How do you identify?
Yes.
Okay. So that is the version, and you can go to the lecture by you can go to the lecture by Srivatsa, the tutorial video, and see how if you take the dual as your primal and take the dual of the dual of the dual will again lead you to the same answer, same standard form of the primal. So do that, have the self work. If you have any doubts, you can ask me again, not a problem. My main concern is to address. I'll do one thing right now, so that is more important. So I'll do one non-standard form primal formulation, and then I will show you how to convert that to a primal. The rest alone, you can have to see the video. Okay, is that fine?
Yes, sir.
Okay, super. All right. So let's say in this formulation that we had, in this formulation, we had something like a constraint that looks like this: x1 plus x3 x1 plus x2 must be greater than or equal to 10. I just make this up. I'm just making this up. All right. So I must produce a total of at least 10 products every day. Below that, I cannot produce. If this was my constraint, or okay, if this was my constraint, how do I convert it to a standard form? A standard form is a less than or equal to. This is a greater than or equal to. How do I convert it to a standard form?
By taking negative.
Exactly. So to convert this to the standard form, I multiply the entire equation by a negative, where it becomes minus x1 minus x2 must be less than or equal to minus 10. So if I multiply the entire equation by a negative, it gets converted to a standard form. Okay. Let's say I had a constraint like this: x1 plus x2 is equal to 10. An equality constraint is not a less than or equal to constraint. So how do I convert that to a standard form? When I have a constraint, let's say I do not have this one, instead of this, along with these two, I have this constraint: x1 plus x2 is equal to 10. I have x1 plus x2 is equal to 10. How do I convert an equality constraint to a non-negativity sign?
We should convert this equation into equation. Like one
Exactly.
is less than equals to 10 and another is greater than equals to 10.
So I will convert this to two equations, which says x1 plus x2 must be greater than or equal to 10, and x1 plus x2 must be less than or equal to 10. Now this is a constraint which is not in the standard form. So what I do is I change this by multiplying it with a negative minus 1. So I will get minus x1 minus x2 must be less than or equal to minus 10. So the original problem will now have two additional constraints, which are x1 plus x2 is less than or equal to 10, and minus x1 minus x2 is less than or equal to minus 10. So this will get added to the problem. So whenever you have an equal to constraint, you will have one additional. So if I originally started off with 1, 2, 3 constraints, I would end up in the standard form of the primal having 1, 2, 3, 4 constraints. Which means how many decision variables will I have in the dual?
Additional 2 variables.
Yeah, so you'll have 4 decision variables, one corresponding to this equation, one corresponding to this equation. Okay. Right. So this was the topic of primal and dual. I hope I have covered it to a certain amount of detail. Do you guys have any other questions here? Any more questions in primal dual?
Yes, sir. I have a question, but this is related to the primal and dual. Okay. The question is that it is given in the 2 years, 2 semester back. Still, I don't understand what is the question. You solve a primal and dual linear programming of a maximization objective. 3 decision variable and 2 constraints of the less than or equal to type.
1 second. You have 3 decision variables and 2 constraints of the less than or equal to type. Okay.
Non-negative restriction applied to the decision variable.
Okay, 3 decision variables greater than or equal to 0.
After solving the linear programming, you find that first constraint is not binding.
Okay.
That is left hand equal less than equal to RHS, and second constraint is binding. That is left hand equal to LHS equal to RHS.
Okay.
Find which are statements are correct.
Okay.
There are 3 decision variable in the dual.
Okay, correct.
So this is correct, okay?
One second. 3 decision variables in the dual. Give me the options. Okay.
Dual variable corresponding to the second constant is 0.
Dual variable for
second constant is 0.
Constraint is 0. Okay.
There are 2 decision variable in the dual formation.
Okay.
The dual variable corresponding to the second statement, second constraint is non-zero.
Equal to 0. Okay. So in this, I will tell you the most easiest solution first. I have 2 constraints in the primal. So obviously, this is a correct answer. I have 2 decision variables in the dual.
Yes.
Correct? Done. The next question would be, how do I know what is the value of the decision variable? Is it 0 or non-zero? Correct? Right? Okay. So, what is my my decision variable is basically the unit worth of resource to me. Correct? That's how I define my this thing. When I solve the primal, when in the solution, I am telling the LHS is less than RHS. What does this mean? What does this imply? I have solved this primal. I have got values for the 3 x1, x2, x3. I substitute it into this equation and see that the LHS is less than RHS. What does that mean? And let's say this is for resource 1, just for example. Let's say this was also 24. I substituted and I got 23. What does that mean? Amitabh, what does that mean?
I don't understand it because in our other courses, this topic is only limited to the equation. It never goes into the deeper.
Yeah. No. I'm not asking you any deeper. I'm just asking you an application-oriented question. When you put x1, x2, x3 in the LHS, let's say I'm producing some amount of cars, some amount of dolls, some amount of, let's say, teddy bears. And I've used 23 units of the 24 units available to me. What have I done? In the optimal, this is the optimum values. I have not fully utilized my R1. Correct? I have 24 units coming in, but I'm using only 23 or 23. That 1 unit is basically going to waste. Correct? So if you are wasting something, what is the unit worth of that resource to you? Will you go out and buy that resource? Will you go out and buy that resource? You are getting from your
No,
farm,
no, 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 no. You will not buy the resource.
you will not buy the resource. So which means that resource is worth nothing to you.
Okay.
So whenever you have a constraint which is non-binding, the corresponding variable will be corresponding variable y will be non-zero. No, sorry, will be zero. Because y is the unit worth of a resource. And I'm not using the resource that I currently have. So it is of no worth to me. Whereas this guy, the second equation that you see, I had 23. I'm completely using 23. So will I go out and buy that resource?
No.
No. You have 23.
You will,
use
right?
23. You will, right? I don't have anything extra. I can get some more if I want to. So what price will you pay for that? That will be a non-zero value. So here the y2 will be a non-zero value.
Okay.
Making sense? So the decision variable for the second constraint is equal to 0. Decision variable for the second constraint not equal to 0, right? Is the yeah. So this is the right answer.
So actually, sir, I don't understand that LHS is less than equal to RHS. So what it means actually? I am in a primal problem. So it's
You're in your primal problem.
Uh-huh.
You're in your primal problem. You're solving this 5 and 4. You're solving this primal problem. Okay. Let's say you're producing your optimal solution is x1 is equal to 2. Wait. Let's say this. X1 is equal to 1. I'm just trying to make this equal to 2 2s are 4, 5, 6, 2 6 are 12, plus 8, 20. Yeah, correct. Okay. Then we can do that. Let's say our optimal solution was this guy. Okay. X2 is 2 and X1 is also 2. So when you substitute this, what is happening? 6 into 2 plus 4 into 2. What is the value? 8 plus 12, 20. This is less than or equal to 24. LHS less than or equal to 24. When you substitute here, 2 plus 2 into 2, which is 4 plus 2, 6. 6 is equal to 6. LHS is equal to RHS. Okay. So when LHS is less than your RHS, this resource is not completely utilized. You are buying 24 units of R1. You are using 20 and keep throwing away the 24.
Correct.
You are next year also you are buying 24 units of R1, using 20, throwing away 4.
Yeah.
When you are throwing away something, will that resource have any value for you? You are making the best possible profit, Baba. You are making the best possible X1 and X2.
So I should not throw it. I should use it.
Where you are not, the optimal solution says do not use it. And every day it's keeping on coming in.
Okay.
So the unit worth of that resource to you is 0.
Okay.
Right? So in the dual, what will happen is y1, which corresponds to the unit worth of resource R1, would be equal to 0.
Okay.
And y2, for which you are getting 6 units, you are completely using the 6 units. Let's say you got a 7th unit. You got a 7th unit. All right. Instead of 6, you got 7. You will now produce one more x1, which means you can sell one more x1, which means your profit will go up. So this resource has some value for you. That is why y2 will not be equal to 0.
Okay.
So y1 and y2 are the unit worth of a resource to you. And how do you find out the worth? If the constraint becomes binding, like this guy, this is a binding constraint, which means the LHS becomes equal to RHS. When it's binding, what will happen is that particular resource is of worth to you. You will look out whether I can buy some more. If you are already wasting your resource, you will not look out to buy some more, which means that worth becomes 0. Making sense?
Yes.
So that is why in
The
this
second
question,
constraint equation.
huh?
So
Can
the
I?
second constraint equation is the RHS is 7.
No. When the RHS becomes 7, my optimum solution automatically will become, instead of 2, it will become 3. Because it's profit maximization, right? So what will happen? It will become 3 plus 4, which is 7. But your question is, this guy will get violated, correct? Even that guy gets violated, then this will also become 6 less than or equal to 7, which means both resources are of no value to you. Making sense? Sorry, both resources will now become valuable to you. No, will have no value. It's less than or equal to. It will have no value to you. I'm starting to blabber. Making sense? Yes, no.
So y2 is not equal to 0. I'm not able to understand. Y1 is equal to 0. I understood.
Okay. Do not take the 7 example first. Do not take the 7 example first. Take only the example of you are producing 2 and 2. Okay? You are producing 2x1, you are producing 2x2. What will happen to the first constraint? The first constraint will become binding. It will become non-binding because you are producing 20 units and you have 24 units available to you. The second constraint will become binding. Why? Because you are consuming 6 units and you have purchased only 6 units. So the unit worth of this Y2, are you willing to go out and buy? Yes, you are. Which means you are willing to pay something for it. Which means your Y2 will not be equal to 0. Remember the definition of your variables. How you defined your Y1 and Y2, right? Where did it go? Over here, right? So my Y1 is the unit worth of raw material R1. Y2 is the unit worth of raw material R2. Will I go outside and buy a resource which I have an excess, or will I go out and buy a resource which I have in deficient? I will go out and obviously be willing to pay a value for the resource which I do not have, which I'm completely binded. So I will be willing to pay for Y2, whereas I will not be willing to pay for Y1.
So second constraint, sir, I don't understand here that when you say that I'm willing to buy, but it satisfies the constraint, then why are you willing to buy?
No, when it satisfies a constraint, you have completely utilized it now. Why is it satisfying a constraint?
Oh, so for next time I will buy something like you are saying.
Correct. What is the unit worth of the resource? Will you go outside and pay for this resource? That is the question.
Okay, so can I think like that I have an go down and these resources actually become 0 if I produce this. So
Correct.
I will buy more. So that
Correct.
is the reason.
Exactly. That is the unit worth of resource.
But sir, to solve this problem, you convert this primal to dual actually. Am I correct? No, no, I'm no.
I'm not converting. No. I am directly just substituting the x1 and x2 values that I have to the equations and finding which all equations have an equal to constraint. Whenever the equal to constraint comes, that particular resource will have a non-negative dual value. Whenever it is not an equal to constraint, whenever the LHS does not become equal to RHS, that resource will have a 0 dual value.
So if the LHS is greater than RHS, then
you are not in the standard form. Convert it to the standard form.
Okay.
Right. So that is why we are emphasizing on. It is very possible to answer that question, but why I'm not answering it is we want you to convert it to the standard form, because if I have to talk to you about greater than or equal to, what will happen when it's a minimization function, so on and so forth, I will have to start teaching you operations optimization theory, which is not the focus right now. We are just giving you the basics. So with only the basics, convert it to the standard form and then do it. Okay.
Yes, sir.
Any other questions? This is also there in your. I was just checking. This is also there in your practice problem assignment number 1 of week.
Oh.
Yeah, of week 5. Week 5, first practice problem. When there are 5 practice problems, the first practice problem is this only. I don't. Okay, I have to share my entire window for this. Once again. Screen. You see, the first practice problem in your week 5 content. Excuse me. The first practice problem in your week 5 contents is exactly the same thing. What is the value of y2? When I've given you the 2 constraints, this becomes equal to 0 and this becomes less than the available. LHS equal to RHS, LHS not equal to RHS. What is the value of y2? Y2 corresponds to this guy. And this guy I have not utilized fully, which means the value is 0. Okay.
So we cannot consider y1 and y2 as cost of, right? It is only unit worth of. I thought we can take it as a cost.
You basically that is why I said in the beginning, not take cost, take it as unit worth. It is how much you are worth for you. It is not the cost at which it's selling. So it's basically like a trade-off. I also have all the knowledge. The seller of the raw material also has all the knowledge. So at what price he can sell it to me, for which I will buy. If he sells at any price greater than my y2, I will not buy the resource. It's not worth to me. If he sells it at any price less than y2, he knows that you will buy, but I will incur a loss. That's a trade-off. Let's not get into it, but that is what it means. The unit worth of resource for the primal problem. Okay.
Yeah.
Again, if you want to understand all of these concepts very beautifully, please go to YouTube, search for the lectures by operations research by Professor G. Srinivasan of IIT Madras. He explains them very beautifully. He is actually our guru. So you do a better job than us also.
What's the name? Operation?
Operations Research, OR, Operations Research by Professor G. Srinivasan, GS, of IIT Madras.
Is it an NPTEL course?
Yes, it's an NPTEL course.
Okay.
But the videos will be available for free.
Yeah, YouTube, yeah.
Yeah. Fundamentals of Operations Research by Professor GS. So you will see that this has more than 1 million views. 42,000 likes, 1 million views in 14 years. So this is like the holy grail. It will give you everything that you require. Okay. In case if you are interested in operations, want to know the basics. Right. All of you good? Any other questions in Primal Dual?
So it's a very nice session, sir, I must say.
Thank you. Do see the tutorial by Srivatsa also. That is also a very famous video in our course. The tutorial video that Srivatsa would have put up. Basically this one. Yeah, this one. Sorry, not the implementation. Optimization. Where is it? Operations delay programming and duality. So have a look at this video. Srivatsa would have also explained it very beautifully in that. You would have done a better job than me also, in fact. Okay. So this was the first piece of the discussion. Any other questions?
Sir, but I don't have any question, but I have an. I'm just requesting you, sir, but please make a live session on the R square values and all the other important concepts because many of us not from economics, so we thought it is easy, but somehow it is not easy.
All right. We will do one session on the. I believe you only asked me. We'll do one session uh, on the Excel output of regression.
Yes.
Maybe
Yes.
that should be fine. Yeah, we'll do that.
Yes.
Yes, Prashant. Yeah, Prashant.
Sir, I have a doubt in just one clarification in the lecture, sir. So, shall I present the screen? Sir?
Don't present it. Tell me in which lecture.
Okay, sir. So, it is in lecture 4.5, that ANOVA table.
Okay, that is what he is also asking me. I will do a separate session on this next week. Can you hold on to that till then? Is that okay?
Okay, sir, sure.
I believe you are going to ask something which is not significant is there in the model. Is that your question?
No, sir, it is about SSC and
Okay.
SSM.
Fine. Yeah, then you can hold it on. Just hold on to that question, and I'll answer it next week. Standard error. Yeah, sum of squares. SSE sum of squares of errors and sum of squares of residuals. Sorry, sum of squares of regressors and sum of squares of residuals. I'll discuss that next week.
Yeah, yes, sir. Another request is, sir, that for the fifth and sixth week, if you give us more questions, that will be great for us. I think
you can take all the past question papers that are there. Quiz 1, quiz 2, all of them have questions from week 5 and week 6.
Okay, sir. Okay.
Yeah. So just take it from there.
Sir, we can ask in the disclosure if I not.
Yeah, definitely, anytime.
Okay, sir. Thank you.
All right. Anything else? All good with primal dual? Super. Okay, then what I will do is I will stop recording and stop the stream.